One of the things that we have to be able to do in algebra is solve for a variable. And we're going to just practice some things you have probably learned before, but we just want to make sure everybody's on the same page. And that is, how do you solve simple equations with one or two steps? So some are going to be as simple as, x plus 5 equals 7. Now, guys, I know this is easy, but remember, it's about building those habits, and it's about learning a process, and it's about leaning in to trusting what I'm asking you to do has a point. Always identify what you're trying to solve for, the unknown in a question, in this case x, and ask yourself, what am I doing to x? In this case, I'm adding 5. So I need to think about, how do I undo addition? And that is subtracting 5. When you subtract 5, you want to do it from both sides of the equal sign. Now, when you do that, you solve. X plus 5 minus 5 is x. Over here, 7 minus 5 is 2. And get in the habit of circling or putting a box around your final answer. Let's do another maybe more difficult problem. 3y minus 7 equals 28. Good? So, start the exact same way. What am I doing to y? Well, in this case, I'm doing two things. I'm multiplying it by 3 first, and then I'm subtracting 7 after. So remember the order of operations. PEMDAS, or like I prefer, PIMA. We are multiplying by 3 first, then we're subtracting 7. That's what we're doing to y. To solve for y, we actually have to go in reverse order up the order of operations. So the first thing to do is get rid of subtracting 7 by adding 7 to both sides of the equation. By doing that, I isolate this 3y, and I get that 3y is equal to 28 plus 7, which is 35. Now I'm multiplying y by 3, so I'm going to undo multiplying by dividing. But remember, dividing is the same as multiplying by the reciprocal. So instead of dividing by 3, I'm actually going to multiply by 1/3. The 3's cancel. I'm left with a y. That's why I did it. I wanted to get y by itself. Here I get 35 over 1 times 1 over 3. There's no common factors, so the final answer is 35 over 3, and I'm done. That's pretty much as complicated as it gets. To be honest, the only way to make something more complicated is to just add some fractions and decimals and things like that that freak kids out. But I'm going to show you some tricks so that those things should never freak you out. So let's try something that looks really scary. 1/2 x plus 3/4 equals 5/6 x minus 2/3. Now, I've taught high school math for so long that I know if I want to intimidate some high school student, all I have to do is give them an equation like this with a bunch of fractions, and they're going to freak. So here's what you want to do. You want to look whenever you get an equation, something with an equal sign, that's got a bunch of fractions like this, I want you to look at all the denominators. 2, 4, 6, and 3. And I want you to think numbers that these 4 all divide evenly. So 2 goes into 4, 6, 8, 10, right? 4 goes into 8, 12, 16. 6 goes into 12, 18. 3 goes into 6, 9, 12. And you're trying to find the number that all of them divide evenly. And that number is going to be 12, and you may have thought of that already. Now, what we mean by that, what you've probably heard from other math classes, is if you were to do this problem with fractions, you would get a common denominator of 12. That's the smallest number that all 4 of these divide in evenly. I'm not going to change all these to common denominators. What I'm going to do is I'm just going to take this entire equation, I'm going to put parentheses around the whole thing, and I'm going to multiply it all by 12. Now what that does is a little distributive property to all 4 of these numbers. And what we're going to end up seeing is we're going to see what is 1/2 x times 12 plus 3/4 times 12. And that's going to equal 5/6 times 12. And then that's going to be minus 2/3 times 12. At this point, you want to simplify each one of these problems. 1/2 times x times 12. 2 goes into 12 6 times, and I get 6x. 3 divided by 4 times 12, well 4 goes into 12 3 times, and you get plus 9. Equals 6 goes into 12 twice, so you get 5 times 2, which is 10x, minus 3 goes into 12 4 times, and you're left with minus 8. Now this bottom equation has the exact same value of x that this top equation has. And doesn't this one in red look a lot easier to solve? This is different than examples we've done before, so right now we need to get the x's together. There's lots of ways to do that. I'm going to choose to do that by subtracting 6x. You could have subtracted 10x from both sides of the equal sign. I subtract 6x from both sides and I get 9 equals 4x minus 8. Now I'm going to add 8 to both sides of the equation, and I'm going to get 17 equals 4x. Then I'm going to multiply both sides of the equation by 1/4. That's the same as dividing by 4. And I get the 4's to cancel here, and I get 17 times 1 over 4 times 1 equals x. That seemed a lot easier once I got to this equation here. The way I got to that equation in the red is I got rid of the fraction by multiplying by the lowest common denominator. Good? Here's an example for you to try. 2x plus 7 equals 1/4 x plus 9. Pause the video now and try this example. Couple ways you could have done this. I'm going to do it the way I just showed. I look at all the denominators, which is pretty easy, but I'm going to exaggerate it so you can see here. There's a 1, a 1, a 1, and a 4. The smallest number that divides all of those is 4, so I multiply the entire equation by 4. I get 8x plus 28 equals 1/4 x times 4, which is x, plus 36. I now subtract x from both sides. When I subtract x from both sides, I get 7x plus 28 equals 36. I subtract 28 from both sides. I get 7x equals 8. and then I divide both sides by 7, which is the same as multiplying by 1/7, and I get x equals 8/7. A harder way to have done that problem is say 2x plus 7 equals 1/4 x plus 9. And some people like working with fractions, so I say harder, but maybe this isn't harder for you. Subtract 1/4 x from both sides. 2x minus 1/4. That's 2 minus 1/4 all times x. So that's 8/4 minus 1/4, or 7/4. So I get 7/4x. Sorry about that. There we go. X plus 7 equals 9. I subtract 7 from both sides. I get 7/4x equals 2. I need to get rid of multiplying by 7/4, so I multiply by 4/7. And that's an area where I really think this idea of dividing by 7 is the same as multiplying by 1/7 makes this a lot easier. Dividing by 7/4 is hard. Multiplying by 4/7 is easy. The 4's cancel, the 7's cancel. I end up getting x equals 2 times 4/7. 2 times 4 is 8, all over 7, and that matches that there. So I feel like I did that problem correctly. The last piece of advice to end the video that I would give you is to watch this video a second or third time when you have a free moment. And notice that whenever you get an equation, you add and subtract on the same side of the equal sign. It's like a balance, right? If you add something over here, you have to add something over here. If you subtract something over here, you have to subtract something over here. Always keeping the sides equal. But when you have an equation and you're multiplying, you have to multiply everything. So you get this number out here, and you have to distribute to every number on every side. You don't get to just do it to, you do it to both sides of the equation, but that multiplication or dividing has to be done to every single number. If you don't do it to every single number, then it doesn't work. So add and subtract on sides of the equal sign, multiply and divide every number. You do that, and I think you're going to do great. Have a good night, gentlemen. Thank you.